Okay, we'll just give it a few more minutes. We'll get started in like maybe 2 minutes or so.
Sounds good. It might be really early for a lot of people, although I guess in Europe it's the middle of the day, 2 p.m.
Yes, it's 2 p.m.
Okay, let's get started. We are recording today's session, so anyone online, thank you for coming. And for those here in person, great to see you in the flesh online. My name is Chloe Rice, and I'm a consultant here at the WHO Hub for Pandemic and Epidemic Intelligence. And this is our second last webinar of our webinar series for 2025, where we'll be talking about citizen science to support traditional surveillance with the Public Health Agency of Canada. So this will follow the same format as all of our other webinars to date. So we'll just provide a quick introduction and then we'll be passing over to Victoria Nook from Public Health Agency of Canada. And there will be some time for questions and answers at the end. But again, as always, we always encourage you to reach out to the speakers after the presentation to follow up on any further collaborations or questions you may have. For those of you who are new here, the dengue and other arbovirus community of practice is a relatively new one, established in November 2024 at an in-person meeting in Berlin. And since then, we've been working to bring together experts from across the globe to share knowledge, share tools, and work on a series of collaborative endeavours. So we just had our WHO Decision Support Simulator workshop with the community just last week or the week before. And we have other initiatives such as a joint publication we're working on, focusing on common pitfalls in dengue forecasting. So if that's something you're interested in, please feel free to reach out. Speaking of, you can join the COP by scanning the QR code in the bottom right-hand corner of the screen. As I said earlier, this is our second last webinar for the year. The time has absolutely flown. So our final webinar will be on the 26th of November with Young from the London School of Hygiene and Tropical Medicine. If you would like to join our calendar for 2026, please email us at the email provided on this slide. I would love to hear from you. Even if you've presented before and you'd like to present an update, please do get in touch. We'd love to feature your work in the webinar series for 2026. And with that, it is my great pleasure to introduce Victoria Nook, who is an infectious disease epidemiologist and a senior scientist at the Public Health Agency of Canada. She specialises in quantitative risk assessments, disease prioritisation, and mathematical modelling of infectious disease transmission and public health interventions. Most recently, Victoria developed and led the Tiger Mosquito Citizen Science Study, a collaboration between scientists, academia, public health professionals, and the public to investigate the geographic expansion of Aedes albopictus in Canada under current and projected climate change. She is also a newly appointed member of our collaboratory technical advisory group. And so it's my great pleasure to hand over to you, Victoria, for your presentation. I'll just stop sharing. Thanks so much.
Great. Thanks so much for the introduction, Chloe. And I'm going to start sharing my screen. Let's see if this works. Okay, are you able to see my deck?
Yeah, perfect.
Okay, perfect. And you can hear me okay? Okay. Great. So thank you so much for attending today's webinar session, and thank you for inviting me to give this talk, Chloe. I'm really excited to discuss today the citizen science study that we've been working in collaboration with academia and the public and local public health units in Canada. And so the title of the presentation is Citizen Science to Support Traditional Surveillance. And the study in particular that we're talking about today is called the Tiger Mosquito Citizen Science Study, which we've shortened to TMO-CS. So Tiger Mosquito, TMO, and CS for Citizen Science. So I'm just going to start the presentation by, let's see if I can, my computer doesn't seem to let me go to the next slide. Let's see. Okay, I'm just going to give it a bit of time. It's still quite early here in Canada, so I don't know if, oh, there you go. Maybe I'll use that. Okay. I do want to do a land acknowledgement. I am giving this presentation today in Toronto, Ontario, and I want to acknowledge that I'm on the traditional territory of many nations, including the Mississaugas of the Credit, the Anishinaabe, the Chippewa, the Haudenosaunee, and the Wendat people, and is now home to many diverse First Nations, Inuit, and Métis people. And the City of Toronto is covered by Treaty 13 with the Mississaugas of the Credit. Okay, so I'm going to address the elephant in the room, because whenever I talk about dengue transmission modelling in Canada, people look at me and give me a really weird look. I admit it is not your typical dengue destination. When you think about Canada, you think about snow, you think about skiing, lots of winter sports, and it is indeed quite cold in certain parts of Canada. So it is not your typical dengue destination. If you go to the Government of Canada website, looking for dengue fever, they explicitly tell you that the dengue virus is not present in mosquitoes in Canada. And so we're not really at imminent risk for local transmission, given that the virus is not present in the mosquitoes in Canada. But why are we concerned in Canada? To begin, in 2016, so this is almost a decade ago, we do routine mosquito surveillance for other mosquito vectors, particularly the West Nile virus vectors. But when we set up one of the traps in 2016 in a part of southern Ontario called Windsor, there was a chance trapping of an Aedes albopictus and Aedes aegypti at the time. And so this was alarming. This is the first record of Aedes albopictus and aegypti in Canada. And we still don't really know where it came from, but given Windsor is very close to Detroit in the United States, there is a large bridge that connects the two, and these mosquito vectors are native in the US. We think maybe one hitched a hike up to Canada and ended up being in Windsor, Ontario that year. So 2016 was the first year that we discovered the mosquito. And in 2017, because of that chance encounter, the Public Health Agency of Canada funded some enhanced surveillance in Windsor, and they found more mosquitoes. They also found the mosquitoes in different life stages, from egg to larvae to adults. And that was a big concern, because that told us that maybe these mosquitoes weren't just hitching a ride from the United States, that they were in fact having their full life cycles in Canada. And so since then, the Windsor-Essex County Health Unit, they've been doing routine mosquito trapping. In addition to other vectors, they've been trapping for Aedes albopictus as well. So these mosquitoes are attracted to different types of mosquito traps. So you use a live CO2 bait for these type of mosquitoes. So in 2018 and up until now, they set up these specific mosquito traps to attract Aedes albopictus, to understand if they were established and where they were established. And so, as you can see in this figure, different color lines represent different years. And since 2016, when they first discovered Aedes albopictus and aegypti, Aedes albopictus has established, and we do see it come back every year during the summer months. So typically our summer months are July to September, with July and August being the hottest year. And so July is where we have seen the emergence of Aedes albopictus, or the detection of Aedes albopictus in mosquito traps in Windsor, Essex. Aedes aegypti, we don't really see that often. We may see once or twice in a few traps in sporadic years, but it is Aedes albopictus that has established in this part of Canada. And so one of the other things that we're concerned about in Canada is although we don't have dengue or Zika or chikungunya viruses in our mosquitoes in Canada, we have travel-related cases of these infections. And so this is a publication that was just published 2 months ago. It looks at travel-related dengue, Zika, and chikungunya in Canada in 2024. And just in 2024 alone, we had 120 cases of dengue from travel. I guess Canadians or travelers coming back to Canada, having visited countries where dengue is endemic and coming back with the virus. We had 1 case of Zika virus, and we had 57 cases of chikungunya. This is in 2024 alone. These bar graphs below, it shows historically, I think it starts in 2012, going up to 2024. And it shows historically the number of imported cases of each of these 3 different pathogens coming back into Canada. And so you can see that although we don't have local transmission, we do see cases of these pathogens coming back into Canada from travellers. And the Latin America and Caribbean region was the top travel destination that was linked to a lot of these laboratory-based cases for dengue and chikungunya in 2024. As we know, particularly for dengue, it was a huge outbreak year in Latin America and the Caribbean. And so we are seeing imported cases that we would expect to see, because imported cases do reflect travel patterns, at least in Canada. And so this is a concern. And the last reason why we're concerned is, given Aedes albopictus is established in a small part of Canada, and I've put a red dot in each of these maps to show where Aedes albopictus has established in Canada. This is work that I did with my colleague in 2020, where we looked at projected climate change. So we know we've got the vector for dengue, chikungunya, Zika virus in Canada, but where is the projected geographic expansion of this particular vector in Canada and in the US? We kind of clumped the 2 together because the data came that way, so we published as both, but we're really focusing on Canada. And if you can see, I guess it expands, it goes up northbound in 2020, and green is the indicator for high probability of the presence for this vector. And so you can see the green is shifting up. So in 2050, with climate change, we're expecting a lot more larger area of Canada to be suitable for Aedes albopictus. And in 2080, even more so. What is really of concern is that about 3 hours outside of Windsor is the Greater Toronto area, where we have the most populous part of Canada. There are over 5.5 million Canadians living in this part. And so it will only be a few years, perhaps a decade, before we anticipate Aedes albopictus may shift into the Greater Toronto area. And so that is a big concern for us. So to recap, why are we concerned in Canada? We don't currently have dengue, chikungunya, and Zika virus in our mosquitoes, at least not that we're aware of. We do, with our mosquitoes that we trap, we do isolate for viruses, and we haven't tested any of them positive for these viruses. So that's great. But we do have Aedes albopictus, and it's established in a very small part of southern Canada. We do have imported cases linked to global activity. So as long as there's global activity, we will continue to see those imported cases. And you really only need to be at the wrong place at the wrong time for those things to happen together. And so if you have an imported case coming back to a part of Canada where we do have Aedes albopictus, and it's in the time of year when those Aedes albopictus are circulating, then you could see how local transmission can occur. And actually, just looking at this part here, if you look at chikungunya and dengue, in many parts of Europe that have never recorded local cases or have only recorded very sporadic cases, now we're seeing outbreaks of local transmission in the hundreds. So this is a concern, and we look at what's happening globally as a benchmark, perhaps like a fortune for what could happen in Canada. And so that's why we're concerned. And especially with the anticipated expansion of mosquito distribution with climate change, these really add to why we are concerned. And so because we are concerned, we do a lot of modelling work to try to forecast what may happen. And so this is work that I did with my colleagues at the agency. This is one of the initial works that I worked on at FAC. And we published it in June 2016. This work actually predated the first Aedes albopictus detection in Windsor by 10 weeks. And so in this work, we looked at modelling chikungunya transmission in Canada. So local transmission, autochthonous transmission of chikungunya virus in Canada in Aedes albopictus under recent and projected climate change. So this is before we had Aedes albopictus, but at the time we just thought, you know what, if there ever was going to be a vector that would arrive in Canada to transmit chikungunya virus, it would be the vector. And so we modeled this. And the modeling indicates that there was transmission potential of chikungunya virus in albopictus. And so we actually modeled in recent climate. So we sort of clumped our recent climate in 30-year averages. Then we did short-term projected climate change. So from 2011 to 2040, and then longer term from 2041 to 2070. And then we looked at different climate change scenarios. So here we've got RCP 4.5, which is the mid-range emission scenario. And then we've got the 8.5 RCP scenario, which is a high emission scenario. And so as you would expect, with time and with climate change, and as the greenhouse gas emission increases, you will see that it goes from just one isolated part of Canada that we identified as a transmission potential spot for chikungunya in albopictus to many parts of Canada. And as I mentioned previously, the expansion goes into the Greater Toronto area. And so this is a high public health concern for us in Canada here. And not only does the geographic range of transmission potential increase, but the duration of the transmission period increases. So it goes from 1 month in recent climate up to 3 months of potential transmission. I wanted to mention also, so this work predated Aedes albopictus arriving in Canada. And in our work, we had actually said under recent climate, Windsor is actually the potential area. This is the transmission potential. This is the only part of Canada where we expect to see chikungunya virus in Aedes albopictus. So I wanted to point out that modelling can really be useful. Modelling can work if you've got the right models. And in this same paper, we also, in addition, so you have chikungunya, we modeled chikungunya in albopictus, but if you don't have the virus, if you don't have the mosquito, then that transmission can't happen. And so we model in 2 layers. The first modeling layer is chikungunya in Aedes albopictus. The second layer is, can we actually have the presence of Aedes albopictus? And we know Aedes albopictus have very sensitive temperature and rainfall requirement. And so we modeled this to see which parts of Canada actually has climatic suitability, and then we combined it with transmission potential of chikungunya. Because you need both. You need the presence of the mosquito and you need transmission potential. And so when we combined the two, what we found was that the transmission potential was a bit lower for Windsor, but it still flagged. It was rather unsuitable, but for most of Canada was really highly unsuitable. But Windsor was rather unsuitable. And then we also had some additional areas of concern in southern coastal BC. Again, we modelled RCP 4.5, so the mid-emission scenario. We had high emission scenario, RCP 8.5, and then we did short-term and long-term projection. As you would expect with higher emission and with longer-term projected climate change, we would see an expansion of this transmission potential. And so what I want to move on to now is we have established that there is concern for dengue and other arboviruses in Canada. We do have the vectors in a very small part of Canada, but surveillance is a huge effort. And in a large country, it has to be targeted. So here, what I've done is I've kind of overlaid Canada. I think most people understand how big Canada is, but I've overlaid Canada on Europe, just to give you a sense of how big it actually is. It actually takes over 5 hours to fly from one part of Canada to the other, and we're only a population of 39 million. So we don't have the human resources to be able to set up surveillance nationally, nor do we need to, because when we look at our risk maps and our models, most parts of Canada is really not at risk. We are able to highlight some of the at-risk areas, and our current surveillance program that are targeted in certain areas validate the models and show us, yes, these are the areas at risk. And so surveillance in a large country has to be targeted. And so that's where our citizen science study comes in. It's a targeted citizen science mosquito surveillance. It's not nationwide. At some point, I think I would dream that perhaps we can bring it up to the nationwide level. But right now, it's really targeted. And so this is a collaboration that my colleagues at the Public Health Agency of Canada started out in 2024. And we did this in collaboration with the Windsor-Essex County Health Unit. We also reached out to the University of Windsor, which is where these mosquitoes have emerged. And we also reached out to their Let's Talk Science, outreach site within the University of Windsor. So what Let's Talk Science is, it's a nationwide non-profit science organization. They deliver workshops, particularly science workshops of different materials, different topic areas in classrooms and universities across the country. Usually the workshops are led by different universities, and universities act as focal points. And so the University of Windsor is the focal point for Let's Talk Science Windsor outreach site. And so I had the chance of reaching out to Michelle Bondi, who's on the call today. And she said, yes, she was interested in sort of setting up some sort of citizen science workshop focusing on teaching mosquitoes in classrooms. And so that's how the study started out. It was just an idea of trying to reach out to kids, trying to get some additional data points as well. But we decided that we wanted to work with kids and universities. And then later on in 2025, we added in the University of Calgary and University of Guelph to help us with identifying mosquitoes and doing some of the tests for the samples that we're collecting. And so why did we choose a community science mosquito surveillance? We don't, when I present this, I've presented this many times. I'm very, I want to express or emphasize that we don't want to take over traditional surveillance. There's no, citizen science cannot really take over traditional surveillance, which is very expensive, but it can be complementary to it. And that is the point of why we started Team OCS. We wanted something that's complementary to traditional surveillance to add some additional data points to our current knowledge. But citizen science also encourage individual participation if it's made accessible. And so there's some power in utilizing the community and getting them involved. It's a great educational opportunity to raise awareness in key areas. So as I mentioned, most of Canada is not going to be imminently at risk for these arboviruses, but some are. And so citizen science presents an opportunity to raise awareness in these key areas. We also look globally to see that it's been community science mosquito surveillance. It's not a new concept, and it's been done in many parts of the world and with much success. And so we thought, well, why not us in Canada? And there's an opportunity for unique collaborations with multiple purposes. And so we were sold on setting Team OCS up as a community-based citizen science mosquito surveillance program to complement what the local health unit is currently doing. And so our goal when we launched in 2024, we did update some of the methods, which I'll talk about later on, but the objectives remain the same. It was to complement existing surveillance efforts in Windsor-Essex County during summer. It was to improve awareness of mosquitoes and disease risk in the community of that key area. The data collected was primarily to inform arbovirus models. So, it's a two-way street. So we want to give something to the community, which is science outreach and education, but we also want to collect some data, and that data will help ultimately inform our arbovirus models. So we have these great models. It seems to be working. It's identified a hotspot in Canada where these vectors have eventually emerged, but is it the best? And so we're always trying to improve our models. And if you want to improve your models in a country like Canada where we don't have local transmission, you really have to be very proactive going out to get the data. But the data can also be collected for other purposes. And one of the objectives of the study was to develop an AI algorithm for mosquitoes, which my colleagues at the Public Health Agency of Canada are doing right now. And so with this in mind, we prepared a training module, a training workshop, and it includes 5 different modules within the workshop where we go into classrooms and we teach these workshops. With the citizen scientists, when I refer to citizen scientists, we have 2 layers of citizen scientists within Team OCS. Firstly, we have the Let's Talk Science volunteers. These are usually students at the University of Windsor. They're 2nd to 4th year students with a science background, and we train them on the Team OCS workshop, and they also then participated in the data collection. And then in addition to training those volunteers, they then went into the classrooms where we targeted children of ages 9 to 14, and they taught this workshop. And then the children were then encouraged to participate in data collection as well. So what we taught in the workshop were very simple, basic concepts about mosquitoes. We taught them about the mosquito life cycle. So you can see the picture in the middle. We have pictures of mosquitoes at different life cycles. So we taught them about mosquito life cycles, and they had activities where they would match up pictures with a particular part of the mosquito life cycle. We also, for the younger kids, had these laminated pictures, and we had I guess items that we said were either protective or not protective against mosquito bites. And so this would help us start a conversation with the younger kids on what are ways that you can reduce mosquito bites. In addition, we had a 3rd activity, which was identifying mosquito development sites. So you can see the picture on the left with some green circles and red circles. The green circles indicate potential mosquito development sites. So these are areas that water can collect and could potentially be a breeding site for mosquito development. And so we went into classrooms and taught kids on how to identify these sites, as well as how to get rid of them. So just simply tipping them out and making sure that there isn't any standing water in your backyard is a way to reduce mosquito bites in the summer months. And then we also had an activity where we presented students with lots of different at-risk situations or potentially at-risk situations, and we discussed, do you think this is an at-risk activity for mosquito bites or not? And then what can you do about it? So we tried to do some science outreach where we taught kids about mosquito life cycles, how to prevent mosquito bites, how to remove mosquito habitats. And then one of the last things that we did was then we tried to get them to collect some data for us. And so our 2024 data collection activity was, we decided to come up with, we wanted, citizen science is successful when it is accessible. And so we wanted to develop a device that everyone could have access to the material and to collect mosquitoes. And so we did this do-it-yourself mosquito pooter. And so this was really just a clean recycled water bottle with some straws, a mesh, some blue tack, and a hole puncher and scissors. So commonly found household items that most kids would have access to. But when we actually went into the classrooms, we provided all the material as well. So they went home with their own mosquito pooter. And they were asked to then go out after wearing protective gear, of course, to try to collect mosquito samples. And so you can see what a pooter looks like in the pictures, in the images on the right. The image on the bottom bottom right is how a pooter is used. So you would get down and suck mosquitoes, or hopefully mosquitoes for the study. I guess what we realized was that this may not have been the best way to collect mosquitoes. It's a great device to collect other insects, perhaps slower moving insects. And so we, part of the activity was we got people to collect mosquitoes, and we wanted them to send us the mosquito sample on this log sheet and send it back to us. And we gave out prepaid envelopes as well. And to try to encourage participation. Unfortunately, we only got 8 samples back. And so, when we debriefed for the first year and decided, what went wrong, what went right, we realized that maybe a pooter, although it was accessible and it was fun, it was a really fun didactic activity for kids in the classroom, it wasn't actually conducive for collecting mosquitoes. And of the 8 that we did receive, some of them were mushed up. And so because my colleagues were interested in developing an AI algorithm, we were particularly interested in being able to identify the mosquitoes and have them preserved in pristine condition. And so I guess our 2024 data collection did not really go the way that we hoped, but we learned a lot. And so then it led us to think about, well, what would we do for 2025? And so during the winter between 2024 and 2025, I reached out to a lot of different folks and, did a lot of research on how mosquitoes are collected. And traditionally, they're collected with large mosquito traps that have attached to a CO2 bait, which is very large and clunky. And in fact, they have to be driven in a truck to these kits that are set up to collect mosquitoes, driven in a truck because they're so big. But I came across this study and it was published in Neglected Tropical Diseases. It was a do-it-yourself 3D printed miniature trap for adult mosquitoes. And this really piqued my interest. What piqued my interest was that what they had actually published was that the trap that they had developed that was printed from a 3D printer was directly comparable to a commercial equivalent. In fact, the species diversity and evenness of the collection was found to be statistically equivalent. But the main difference was instead of $200 for a commercial trap, which is also really large and chunky, these 3D printed traps are miniature traps. They are about 15 centimeters in height. They weigh about half a kilo, possibly less than that. And all of the material you can purchase from Amazon and put together, and it costs $20 US. And so this was a game changer to be able to potentially set up a citizen science study that is low cost and accessible potentially because it is low cost, that we could be able to distribute some mosquito trap kits to volunteers to be able to collect mosquitoes for us. And so when I reached out to them, to this group from Salt Lake City Mosquito Abatement District, they were so kind. They actually donated 14 of these traps. I had asked them if I could get the blueprint for the mosquito traps to print them out myself, which they've made publicly available. But they actually donated 14 traps. And so I turned these traps into mosquito kits. So here on the left-hand side, you can see the mosquito kit. So the trap is the item that's in the left-hand side. On the left-hand side, we paired this up with some thermos that I got from the dollar store. We have mesh bags from the grocery store to be able to collect the mosquitoes. The most expensive part of the kit was the power bank batteries, and so that was about 35 Canadian dollars. And then we had some tins for collection, and we were collecting specifically for June, July, and August. And so this kit, it weighs less than a kilo. And so I had actually bought this kit to the health unit just to show them, and they were comparing it to their commercial kits, and it made it so much easier for volunteers to be able to collect mosquitoes using these small kits. In fact, we have plans for me to potentially give a few of these kits to the health unit in 2026, where they'll set it up next to their commercial trap to see if we get the same species distribution and evenness that the US got, because things are different in Canada, and of course we want to test that out here. But this is the picture on the right is what a kit would looks like when it's set up in a backyard. And one of the things is we do need dry ice, and so that thermos is filled up with dry ice. And then that dry ice is emitted over time slowly in the air cap, the little blue air cap that's coming out of the mosquito trap. And so this adult mosquito collection of 2025 was a collaboration between Salt Lake City, who generously, Mosquito Abatement District, who generously donated the traps to us, but also the Let's Talk Science and University of Windsor. They were crucial because I gave these kits out to the Let's Talk Science volunteers. I didn't have enough to give out to kids in schools, and that's why we have a second collection method for the kids in schools. But with these kits, I was able to give out to the volunteers who were doing the workshop in schools, and they went and set it up in their backyards and were able to collect mosquitoes for me over the summer. We collaborated with the University of Calgary, who have some students currently working with me to identify the mosquitoes that we collected, and of course in consultation with the health unit to make sure that we didn't duplicate in where they're they're collecting their current mosquito traps, they've got their routine surveillance. We don't want to overlap with that. And so a lot of this work was done in consultation with the health unit. This is what we ended up collecting for the 2025 period. Volunteers were asked to put the mosquitoes in their freezers. So this was not a real-time surveillance study. We did not immediately send it to the University of Calgary for identification. Volunteers kept it in the freezer, and then I went to Windsor in September, collected all the mosquitoes, and then I sent the mosquitoes by airplane to the University of Calgary, where they're currently being identified. So part two, we wanted to also give something to the kids that were being taught the mosquito workshop in classrooms, but we didn't have enough of the mosquito adult traps. Despite it being low cost, it's just, we didn't have enough. Each classroom has about 20 to 30 kids. And so we wanted to come up with a way that they could participate actively in the study. And so we came up with Ovi sticks. So Ovi sticks are just craft sticks clipped on with a butterfly clip to a black pot. And so we distributed these materials in the classrooms with self-addressed envelopes, stamped envelopes as well, to encourage participation. And these are just examples of what they would look like. And kids would, with their permission of their parents and family, would then send the eggs back to us. This is what they look like. So some of the sticks that were used, you can see there's black dots. So these are all mosquito eggs. So despite it being a very low cost method of collecting mosquito samples, they are an effective way. And the other thing is, and I was telling a lot of the kids in the classrooms, because I actually did some of the Team OCS workshops in Toronto, and it's a really effective way of mosquito control, a natural way of mosquito control, because you collect the eggs and then you destroy them, and that's hundreds of mosquitoes at a time that you're killing. But just to give you an example, these sticks were then also sent to our collaborators at the University of Calgary by envelope. They would put them in the lab and they would then stick them in a broth that would try to activate the eggs and then grow those eggs and hatch the mosquitoes and identify what those mosquitoes were. Now, we don't have results from this right now, and unfortunately we didn't really get a huge uptake, so this is something that we're going to rethink, but we got about 8 sticks back from the community, so and they're currently we still haven't identified the mosquitoes yet, but we also did a third data collection for 2025 because we just sort of went all out and decided what are different ways that we can collect in this study in a low cost way. And so we partnered up with the University of Guelph. They do a lot of water sampling detection for other pathogens. So particularly during COVID, they were sampling wastewater for COVID. And so I reached out to one of my colleagues there and said to him, you know, do you think we could potentially detect the DNA of Aedes albopictus? And he said, sure, why not? And so the figure on the left shows you what a water sampler is. It's really lightweight, really small. They are also coincidentally 3D printed. So we're trying to use very low cost material for the study to make it accessible. They cost about $5 each. And inside the sampler, there are 3 different ways to collect genetic material. There's a Q-tip, there's a membrane, and a gauze. And these are the lid goes back onto the sampler before it's deployed. The picture in the middle and on the right, they show what a deployed sampler looks like. So it will sit in the water. It shouldn't hit the bottom and it shouldn't be floating on the top. So it's going to be submerged and in the water completely. And we leave them in the water for 5 to 7 days, and then we go back and pick them up. And so we had some of our Let's Talk Science volunteers do the water sampling for us, but we also had citizen scientists. So there were just people who I had engaged in the community that I knew lived near water bodies, and I gave them samplers and they deployed them and then sent them back to me, and then we got them as quickly as possible to University of Guelph. We also unfortunately do not have the results of this of the water samplers that were deployed right now to share, but these are forthcoming. One thing we realized was that people are very curious in the public, and so unfortunately we lost a few of these just by I guess people taking them out of the water completely. They didn't even leave them on the side. They just took them home maybe to play around with them. I'm not sure. So we started putting laminated tags. So you can see the sampler on the right-hand side. That's got a tag. They had a QR code that linked to our study. But we found that that wasn't a complete deterrent for people. So we need to rethink how we stop people from nicking off with our samples next year. But, you know, this is the third way of data collection. And I guess the results are to be seen to see whether we get some interesting results from this. So I did want to share some preliminary results. On this map shows Windsor, Essex. It is overlaid in colour with the risk maps that I had developed for dengue, the dengue model using 2023 climate. So it's a little outdated. So this is work that we're constantly trying to update. The yellow parts of the map shows that this area is partly suitable for dengue transmission via Aedes albopictus. The orange part is that it's rather suitable. And so you saw previously the publication that we published in 2017. It had one dot for Windsor. And so with time, technology has improved, but also data has improved. And so now I have much higher resolution climate data. Here I'm using data that's 1 kilometre by 1 kilometre grid. Previously, I had 44 kilometre grids. And so that's why you saw one dot across Windsor, Essex. But now, a decade out, we have much better power to be able to distinguish which parts are more at risk and which parts are not. Also on this map, we've got black dots. Black dots are the traditional mosquito surveillance that the health units do. There's 53 dots, but this is over 10 years. So right now, they really only have about 15 or so dots each year. The dots have moved over time, but they've set on a set of 15 trap locations that they have currently. And so it looks like there's a lot of data points for the health unit, but really they've got 15 data points or so each year now. The green dots and the blue dots are the residential data points. That's the Team OCS study. I have also de-identified these dots, so I've kind of moved around the geographic coordinates a bit, but for most part, they show across Windsor, Essex, where we're getting our data collection from. So the blue dots are the water samples. We got 6 of them. Some of them overlap, so you probably only see 4 dots, but some of them are really close together. So we've got 6 water samples, and then the green dots, we've got 11, including some outside of Windsor. So I have a colleague in BC, in Vancouver, who set one up in his backyard. I've got one data point in my backyard as well. They're our controls, and we don't tell the university which ones is which, so that the student, there's no bias in the identification of the mosquitoes. So I don't have results to share. What I can say is that some of these green and blue green data points, it indicates that the student who's working on the mosquito identification seems to show that there are striped legs mosquitoes that are similar to tiger mosquitoes. And so we think that there are some tiger mosquitoes in those green data points. And what's interesting is some of them are very close to the black data points that the health unit traps, and they've never actually had any positives in those. So that could be something new from this study. The other thing is, I want to say with citizen science, one of the value of citizen science is you actually get residential data points. When you're trapping at the health unit, you can't really go into people's backyards. I mean, there are some farms, but for most part, they're trapping in open areas where there might not be people living in those areas. With citizen science, and I think this is one of the power of citizen science, you get into those residential areas. And from a public health perspective, those are the areas of most interest. If you want to know if the mosquitoes that are vectors for viruses that can cause illness in humans, you want to know if they're around people living in the neighborhood. And so I think this, even if we don't see a lot of data points from this study from 2025, just knowing one, if one of those switches to a positive data point, that is of value. And what I plan to do is to consult the health unit as well. And also that will help them decide if they change their, their trap locations for the following year. So there's lots of different outcomes from this study. In addition, the health unit will be in charge of communication. So we've already agreed upon this. that I will pass on any information of new data points that are positive for Aedes albopictus to the health unit. What they have historically done is if they've trapped mosquitoes or Aedes albopictus in a residential or near a residential area in one of their traps, they put a doorknob flyer on the doors of people in the neighborhood just to say, hey, you know, we've trapped this mosquito. It's a vector for dengue, chikungunya, and Zika. We don't have these viruses circulating in Canada, but, you know, we just want you to know, just take care of yourselves and try to prevent mosquito bites. So there is a component of this study that could have some public health outreach in the neighborhood. And I think that is something of value as well from citizen science. So expanding on to TMOCS, where are we at next year? Right now, I'm once I get the preliminary results, I'll be consulting with my collaborators on next steps. But here, this is a map of all of Canada. So I've already identified Windsor Essex is a hotspot, and so we've got TMOCS here. I have a colleague in BC, and they are currently doing their second year of mosquito surveillance, and they're looking at both the West Nile virus vectors as well as dengue vectors in southern coastal BC. So this is another hotspot of the map. We've never found these vectors yet, but the absence of the vectors does not mean that they're truly absent. You got to really look for them to be able to say definitively that they're not there. And so we're just awaiting the second year of their pilot mosquito surveillance program. But I've been talking about potentially expanding TMOCS out there. And because we have this partnership with Let's Talk Science, and Let's Talk Science is national across different universities, there's a potential to collaborate with Let's Talk Science in British Columbia at one of their partner universities and expand TMOCS there. And then third thing I've got here is I've got QMOCS. So what does QMOCS stand for? Culex mosquitoes. So in the last 5 years, Culex pipiens, which is a vector for West Nile virus, has traveled across the east coast of Canada all the way out to Alberta, particularly in Edmonton and Calgary, which is their most populous parts of Alberta. And so this has been a concern, and funding has dried up. There isn't really a routine surveillance program set up there because it's really expensive. And so one idea I've bounced to my colleague there is perhaps QMOCS for Culex mosquito citizen site study. So these are all sort of potential initiatives, and I'm really hoping to continue on with TMOCS in Windsor in 2026. So this is where we're at right now. So I'm going to wrap up my my presentation on some reflections on citizen science. I think partnership and communication is key. I think throughout the presentation, you can see that this work was not done alone by the Public Health Agency of Canada. It really has taken a lot of partnerships and constant communication with different stakeholders to set this up. I would advise anyone interested in citizen science to explore many options because it will not always work out. And indeed, if you look at the data collection for 2024, that didn't work out, but that's part of the learning experience. In 2025, perhaps our OV traps is not as effective and the water samplers to be decided, but we have the physical mosquito trap. So explore as many options as possible because you'll more than likely get one of them come back with some positive results. It takes time to set up this framework, and so this is an initiative that my colleagues and I started in 2024. We're heading into our third year. We're not fully set up yet, but we're learning a lot, and I think with each year we do learn and it improves over time. It has been extremely rewarding with very unexpected impacts. It's been rewarding just working with the universities and the local health unit and just seeing the impact that it has on students directly. On the students that are training the younger kids in classrooms, it's been a really great training opportunity, and I've had the opportunity to speak to those university students, and they have said that it's been a really great learning opportunity for them to see a real life science experiment in action and being a part of it. So that's been great to see and support. We've got new collaborations. So with each year, and even in 2026, you know, I see that there's more and more collaborations coming out of this. And I think citizen science is not something that you can do in silo. And so having these new collaborations is a wonderful way to keep this citizen science project going. There's a specimen preservation part of this as well. So in giving this talk to many different audience, someone from the Alberta Museum had actually asked me if he could get samples of the mosquitoes once they've been identified for the museum. And I thought, wow, this is great. I actually don't need to keep the mosquitoes. I have no desire to keep the mosquitoes. I want to know where they are and how they fit in with the models. But if it can be used elsewhere, that's fantastic. And so a lot of the samples that we've collected this year will ultimately go to the Alberta Museum and be preserved and showcased there. And I've been asked a lot about, success, like what is success in citizen science? And this is a question that I don't think I have the answer to. I think it really depends on a lot of factors. I think success is not something that is always quantifiable. So if I get data points for the model to improve the model, yes, that is one way to quantify success. But just being able to reach out to communities, working with the local health unit, with the provincial health unit, with academic partners, that has been, to me, a success. And I think there are so many unexpected impacts of citizen science that I'm still learning about. So I really think that it is a worthwhile cause. And so finally, I just want to end the presentation with acknowledgements. Of course, Let's Talk Science outreach team at UWindsor, Michelle Bondi from UWindsor, who accepted my cold call in 2024 and decided she would help take this project on. I've got Dr. John Sergichian at UCalgary, Dr. David McCarthy at U of Guelph, helping me identify the mosquito samples. Windsor-Essex County Health Unit has been so receptive. At no point did they feel like I was encroaching on their territory. They really wanted to be a part of this work, and they see the benefits of this work and how it's complementary to their routine surveillance. I also want to acknowledge colleagues at Public Health Ontario who allowed me to bounce ideas off of them, as well as my colleagues here at the Public Health Agency of Canada, and of course, anyone who participated in the study. I've got a QR code in case anyone wants to scan it, take a look at the study, and also to reach out to me after this presentation. Thank you so much.
Amazing. Thank you so much, Vicky. That was a really exciting and interesting presentation. We are a little bit over time, unfortunately, so I am going to push any questions to an offline format. So anyone who's got a question either on the call or from the recording, we'll provide your details, Vicky, to the community and they can reach out for any questions. But thank you so much for your presentation. That was really great. And thank you to those who could attend. We will be back on the 26th of November. So keep your eye out for the invitation. You should have it already. But yeah, thank you all so much and we'll see you soon.
Okay, great. Thank you. Bye.
Thanks.